today my presentation is about like how to improve productivity with using AI models for the SQL task, and this is a case study on a telecommunications company. So I will go through today's agenda. So I'll quickly talk about the motivations and introductions about the field of text-to-SQL. Then we provide like some literature review that they have been adopted in this field. Then we provide like about like our methodologies, and we analyze them throughout 3 phases of the experiment. Finally, like we will discuss about limitations and how it is significant in that we have conducted in our company. Right, so for the motivation, it was started from my company board that we want to extract the information from the dashboard using data business and data analyst. And for the stakeholders, it find it very difficult to extract the information coming out from the dashboard, and they want to go back to the data set in order to get some further informations. However, like that task was not trivial because like the data set is complicated and it requires a lot of knowledge with experience to actually execute those commands. Therefore, it might take a lot of time, money, and effort to get one insight in which is not convenient. For stakeholders, we want to get something that on spot during our conference, so we can come up with quick decisions. In order to address that, there have been so many solutions for it in the world of deep learning. And some of them we call that to be text-to-SQL techniques, which mean like we convert the natural language into SQL and then like allow them to perform any fast query generations. So there have been like 2 main type of SQL text-to-SQL models, which mean like sequence to sequence, that use like fine-tuned transformers on your SQL and tabular models, and then you go it for direct query translations. And the second type is like non-SQL to SQL, which mean like you will be for the relation-aware self-tension models for complex queries. These one have been successful in the past 20 years. However, like with the recent advancement in large language models, this kind of idea has been extended into something called RAG-based systems, which mean like retrieval-augmented generations, that allows you to come up with the model itself, with the query itself throughout simple prompts. And it had been showing that like using the RAG-based model or the LM-based text-to-SQL, it achieved like more than 86% of accuracy on synthetic data called Spider. So it is something that like the research field had been focused on, and we are trying to look to adopt it in our company setting. However, like the application of all these tools, including the traditional text-to-SQL model with the RAG-based model, confront some challenges. So one of those is like most of the synthetic data, most of the traditional technique, they only perform on synthetic data called Spider and Bird, which is like well structured and very clear and very well annotated. However, like in reality, the data set from the real world application is not that simple. They might contain like a lot of errors and a lot of domain specific terminologies that cannot be interpreted easily from a deep learning model. So, so it is very hard for us to migrate like some traditional method and apply it directly on our real world data set. Additionally, currently, like we only evaluate these models on like traditional models based on some evaluation metrics like execution accuracy and execution match, even though like they are helpful, but they can only tell you about how good a model is, and they don't care about like the productivity or how it's going to help the company, which is like the key information that we want to see in a company setting. So, to sum up that, why we are addressing this one, because like we want to test the AI models to replace the traditional text-to-SQL tools when they are limited in handling complex and domain-specific datasets, and they are unable to empower non-technical user with easy database access. And we expect like the AI tools will allow us to do it. And finally, it's like our contribution lies in the proposed new metric called PGI that can measures about the productivity of an employee that using AI models compared to non-using AI models in terms of time and accuracy improvement. Right. So about methodologies, like we prior to our experiment, we have benchmarked a lot of RAG-based models on synthetic data, and we filtered out like two best options called Llamaindex and Vanna AI that in red and blue color respectively. So these two models, they have very similar frameworks where like the user, the text, and the intent recognition is processed in the first phase. The only difference is like the large language model will be used at the sixth phase for the Llamaindex and at the fifth phase for the Vanna AI. So yeah, for the SQL generations, we can use like all kind of large language model from Ollama to GPT or to like a C3 model, which we did all of them during our experiment. Then we will decide to test out like, okay, out of these two, which is the best now. We want to see like, okay, out of these two, which one going to be more compatible to adopt them in terms of industrial data setting. And another contributions, another methodologies we have is like a new metric. So opposed to the traditionals executions match and execution accuracy, we want to quantify the impact of AI tools on the employee performance. And our paper introduced like a new index called productivity's gains index. It desired to capture like both aspects of productivity, including like the time and the accuracy after and before using AI. So you can see here's like we using the accuracy before and after, B standing for before and A standing for after. So to gain these values, we want to use execution match to compute these two values. And then we and for the second one here is like before the time that we use the AI tool and after the time that we use the AI tool. To conduct this one, we are going to check the resources, how many resources we use for computations, and how many hours, how many times per queries that we have to that we have taken to execute one query. So combine them together with a different weights, we come up with an index that can capture the dual aspects of productivity. So the experiment has been the experiment is divided into three phases. Before doing any experiment, we have to collect the data. So like following like any other natural language generations papers, we adopt our tools on synthetic data set like BERT and Spider. Because like they are the most popular, and then we collect our own data from the company Telstra in order to see, okay, if there's any difference from the performance of synthetic to the real world data set or not. And the data set from Telstra is more complicated, where they have like 25 tables with like 1,600 columns and a lot of and like 30,000 entries. So they and remember, like they are not well annotated, which means like you have to identify your own foreign key, your own primary keys, and this is like very complex for us when we do any retrieval task. So our experiment setup is divided into three phases. In the first phase, we are going to test which AI models going to perform the best on the synthetic data BERT and Spider. And then from that, we're going to proceed one only good models for the phase 2 and phase 3, which mean like, okay, with that best model, how are they going to perform on our real world data set, and how much difference between the performance from the real world to the synthetic data. And finally, we compare them with like the human work, which mean like, okay, on the real world data set, how much improve of the AI's model compared to the real humans. So this is an illustrations of how we do in our last phase, which mean like we hire some data analysts. So these people are like senior data analysts, and both the models and these data analysts will be provided with the same DDL documentations. Without like they don't know what data in, they only have like a list of DDL. And then like we will ask them like different questions from easy to hard and expect both of them to answer. And then we will evaluate which one to be correct. So the question we asked them here are some example for it. And we divided these questions into 5 types, like aggregations, recursive, conditional queries, trend analysis. So they are ranking from easy to hard with the expectations that like analysts will perform it better. Right. So let's discuss about the results. In the first phase, we are trying to see like, okay, which RAG-based model or which AI model will achieve the best performance on the synthetic data. So these you can see here, BERT and Spider, they are synthetic data, and they are computed and compared based on execution accuracy, execution's efficiency, and the time for you to run each of the queries. And out of all of them, you see like the Llamaindex, which means like the framework in the red color with the backbone of ChatGPT's 4 that we run in Azure. It consistently performed better in most of the benchmark, in most of the metrics. And we decided like, okay, Llamaindex is actually the best. But however, when we do that in second phase, we realize that like Llamaindex don't allows you to customize the instance of the large language model, which means like it will provide the higher risk of the information leak. Therefore, we decided to stop using Llamaindex for the experiment. Hence, Vanna AI is selected for the next phase. And currently, at the moment, in Telstra development team, we still explore the potential of customizing Llamaindex. As we can see, how good it is based on this model right here. Right, so using Vanna Index as the best model, we are going to proceed to apply them on the real world applications. And on the chart here, you see there's two main chart, A and B. So the A is like a radar chart about the time and the accuracy match in the triangle. On the two data set, Spider, on the three data sets, Spider, Real World, and Bird. So what I can see here is like, okay, first of all, we are using GPT and we are using Ollama as a backbone for each of these charts. And the common trend here is like the time to run each query on all these data set in the real world, it took less time. So which means like if you run a queries using AI models, it took less time compared to synthetic data. And also it, however, it like goes with like low accuracy. Similar trend can be seen in the backbone of Ollama, which means like real world took less time, took highest time, but the worst accuracy. However, to compare between GPT-3 and Ollama, we decided like GPT actually better. And one of the insight here is like there's significant difference between real world data set and application data set and synthetic data set, where synthetic data set took like less time and real world took like twice the durations to run this model. To confirm our explorations, we use the t-test evaluations in the second chart to see. And this t-test evaluation, if you can see in the blue box here, with very low value of t, it confirmed that like, oh, okay, Vanna AI with the backbone of GPT 3.5 is actually more significant to perform on the synthetic data compared to other types. So a conclusion here is like we confirm that the real world data set is more complicated to run with the low accuracy, and GPT 3.5 is the better backbone models. So we comes to the final analysis where we want to know, okay, between AI and human, which one is better in terms of like times and accuracy. So due to like the time restrictions and the budget, our data set, our experiment can only include 2 senior analysts. So we provide them like from 5 types of SQL generations. They will have like 4 to 5 questions that you can see here. And in general, for Vanna compared to humans, we can see that like the AI tools have like 10 times improved overally on both on my PGI index, which mean that the times and the accuracy has been improved by 10 times for the analyst 1 and 9 times for analyst 2. And remember that like these two analysts have the same amount of years working in Telstra with like the same knowledge of qualifications. So and for the difficult task, meanwhile like humans fail to answer that, but like the AI tools, if you can see in the trend analysis, humans fail to answer some of these questions, some of these SQL queries, but AI can do them, even though like in a long period of time, 14 seconds to 12 seconds, but it still gives you some answer. So therefore, like we can conclude that like the AI model can perform very complex SQL queries with much higher accuracy, 10 times to 9 times. Right. So for the discussions, we have demonstrated that like AI models, in this case, Vanna AI, has provide a superior performance in terms of accuracy, time efficiency, and productivity compared to humans. And PGI has our contributions has effectively quantified the AI impact on the workplace. And AI tools, if we can use them retrospectively, it can be act as a virtual senior analyst, which can provide on-spot decisions or on-spot insight analysts for all stakeholders. And the future work here is like we want to incorporate the financial metrics, which mean like how many tokens have been generated into PGI, so we can evaluate the cost effectiveness compared to like human salary. And limitation here is like we have two limitations actually. First is like the Llamaindex has not fully explored, and secondly is like the population size of analysts here is not controlled due to the restriction of our company. Right, so further study has been done in the last 3 months in Telstra. So we actually, like after this paper, we also try to do some rollout phase test on our company. And we find out that like, okay, during the last 6 months, analysts have provided like about 6,000 SQL queries. And each query, like previously, like based on our inner estimations, it took like 15 minutes to run most of them. However, like now using the Vanna AI tools, it only costs you about 5 seconds to 3 minutes, including the reprompting. So the key metrics we kept seeing here is like the number of hours has been reduced successfully about like 75%, and the accuracy also increased from 90% compared to 50% previously. So because like 50%, because like our analysts also include like junior and include like some graduate students. And for operational benefits for such company like Telstra, we empower like 11 non-technical stakeholders to retrieve insight independently without asking for the help of analysts. Therefore, they can come up with decisions faster and achieve better business goals. So this is like something that we have done, and we feel like it can be extended in the future work in terms of AI models. So that should be it for my today presentations. Thank you.